Okay, so let's define that first. So theoretical probability. All right, Ishmahan, Hiba, focusing. All right, theoretical is what should happen. So when we flip a coin, how often should we get tails? 50%. Is that what always happens? No. If I get a heads, does that mean I have to get a tails the next time? No, it might be heads, heads, or it might be heads, heads, tails. Okay? But either way, that theoretical is what's supposed to happen, and then experimental is what actually happens on these. Okay, so theoretical is what should happen mathematically. Experimental has that word experiment in it. And it's what actually happens. All right, so if we take a look at the coin that I handed out, you guys all got one, right? This isn't an actual coin, obviously, but it still serves the purpose. Okay, if we look at the coin, we have it's yellow or red. And I'm just writing that in our notes because it's not a normal coin where we have heads and tails. So we're just reminding ourselves when we look back at our notes that we had a coin that was either yellow or red. Okay, I want to know what is the probability of landing on red. So on our coin, what's the probability that if I flip it or I throw it up in the air that it'll land on red? It's one color out of 2, so half, which Ash already computed into a decimal, 0.5, which is 50%. Sorry, even chance. It should land about half and half on red and yellow, right? All right, there are 22 of us, so we are all going to flip our coins 5 times. Okay, so 22 times 5. We're going to do it 110 times. Okay, so out of 110 flips, theoretically, we should get red how many times? Yeah, how did you find 55? Yep, you split it in half. So we would do 110, that's how many times we're all doing it, together, times a half. So splitting it in half, similar to dividing by 2 when we have just a fraction with a 1 on the top. So 110 divided by 2 is 55. So as a class, we should get red 55 times. So everyone is going to take their coin. You are going to flip your coin. Now, way you can flip it, most people, they like to flip it with their thumb, right? Or you can just throw it up. It should work as long as you throw it up and kind of try and get it to spin a little bit. Okay? You are going to flip yours 5 times. And out of your 5 times, you're going to count how many times you get red. Okay, so 5 times total. How many reds do you get? Ready, go.
3 times.
Well, don't say it yet. Keep it in your head. So flip your coin 5 times. How many times do you get red out of the 5? You need to keep a tally. You can use a whiteboard for that. All right, come on, how many did you get? 4. Abraham? So? Christy? 2. Carmelina? Sarah? 2. What? 2. 2. Liv? 2. 2. Alex? 1. Tony?
2.
2. Joseph?
3.
3. Grace? 4. Maria? 2. 2. Nemo? 2. Tristan? 2. 2. Dusty? 3. Bobby? 2. Alright, now we gotta add those all together. Yikes. So much work today. Alright, so we flipped it 110 times all together. So we have 4 plus 2 plus 4 plus 2 plus 2 plus 3 plus 2 plus 3 plus 4 plus 0 plus 5 plus 2 plus 2 plus 1 plus 2 plus 3 plus 4 plus 2 plus 2 plus 2 plus 3 plus 2. We get 54. So did we get it exactly 55 times? No, it is really close, right? So experimentally, we got 54. The other class, we were off by I think we had 72. That's nuts. All right, so for our experimental probability, we got it 54 out of how many times total? 110. So when we ask to find experimental probability, we're actually comparing how many times did it work compared to how many times total we did. So then we're going to put that into our calculator, simplify it, just like we would in a normal one. And we get 27 over 55. Mrs. Merrill? No. She should be with Miss Keenan. Thank you. Oh, it's periods, right? She's not with Miss Keenan. I don't know if she is. IDK. Anyways, 54 out of 110 simplified is 27 over 55, which to me that doesn't make a whole lot of sense. I can't imagine 27 over 55 as a fraction, so I'm going to make it into a decimal, 0.49. Which is about what percent? Right, it's close to the 50. This would be 49% when we could just convert it. So were we close to the 50% of theoretically what we were supposed to do? Yeah. Okay. Personally, if you look at everyone's numbers up there, out of 5, you should have gotten about 2 or 3. Did most people get about 2 or 3? Yeah. Yeah, there's a lot of 2s, a couple 3s. Couple 4s. There's 4 4s. And we had that 1 5, which was kind of goofy, and that 1 0, which was kind of goofy. What's goofy is that those people, I think, were sitting at the same table. So goofy. I'm just kidding. All right, so that's our experimental probability. We're going to run 2 more experiments. So, Destiny, can you go? All right. Marianne's going to go around and collect everyone's coins. Thanks for walking. Appreciate it. So everyone have a coin ready, put it in the bag, and then you are all going to get a dice. So Marianne gets your coin back, you get a dice. Ryan! Welcome! How are you? We're in the middle of notes for K-1. Destiny just went when she was All right. We already went through the work of finding our theoretical probability earlier, so we're just going to keep it the same. Thank you, Maya. Crushing it. You're the greatest. Amazing. Thank you. All right, so we're going to find the probability of rolling a 3, because that's what we did in our warm-up. Okay, so probability of rolling a 3. So how many threes? What? That was creepy. How many threes are there on a dice?
7.
1. Out of how many options total on a dice?
16.
Oh my gosh. This dice I just handed out. You're right. It does depend. So there are like D30s or D100s. There might be more, but on this special dice I just handed out, a regular dice, it's 6. All right, so that's 0.16 repeating. So about 17%. All right, this time we are going to all flip our coin, we're all going to roll our dice 10 times. So this time we're going to have 220 rolls. We're going to do this 10 times. Theoretically, as a class, how much should we get?
17.
17%. So we're going to take 220 times, what's our probability? 1 out of 6. I like to use fractions because they're exact versus the 17% is a little rounded. So it might not give us as close as a chance as we want. So 220 times, 220 times 1 divided by 6. We get the 36.6 repeating. So we should, as a class, if we all roll our dice 10 times each, we should get about 36.6 repeating. All right, so you are going to roll your dice 10 times. If you need to keep a tally, what's hard is you have to keep count of how many times you rolled it and then how many threes you got. Okay, when you have your answer, out of your 10, you're going to come write it up on the board. So roll your dice 10 times. Count how many threes you get out of 10. How many threes you get out of 10. Whoa. When you have your number, you can go ahead and write it on the board. Rolling it 10 times total. Did you roll your dice? 10 times. How many threes do you get? There's multiple markers up there. You guys don't have to write them in linear order. So if somebody wants to start writing on the other side of the board. There is just Carmelina's next. Liv, did you tell someone to write it up there for you? I'm gonna go right. Now make sure we get everyone's numbers up there, otherwise it won't be accurate. There's a whole line now, so you'll be after Grace. Grace, when you're done, can you give it to Eloise? What? Carmelina. She's sitting with a black sweatshirt and the white stripes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So we're missing 2 more people. If you didn't write your number on the board. Did you write your number, Alex? You wrote your number? Tony, did you get your number? You wrote it up there already? Oh. Did I miscount? Yeah. That's a 2. That's a 6. We're missing 1 more person. Otherwise, we have to change our number. No, because Ryan came in. Ryan, did you do this? Yeah. Alright. I'll do it real quick then, I guess. I don't know. Because we gotta have, otherwise you have to redo that. 1, 2, 3, 4, 5, 6, 7, 8, 9, So I got 2. Okay. So, as a class, there's 2 6s.
Yeah, surprisingly.
We got it 46 times. So, that time, were we close? It feels really far off, but this time we doubled the amount of times that we were rolling our dice. So because we doubled our times that we're rolling our dice, when we find that percent, it might not be as far off as we're feeling it to be, because it's only 10 numbers, but we did it 220 times. So out of 220, 10 isn't as significant as it would be out of 110. So let's figure out our experimental probability. So 46 out of 220. Simplify it, so I'm going to use my Desmos calculator. Is 23 out of 110. Which is 0.21. Right? Because that 9 tells us to go up. So about 21%. So overall, in this overall scheme of things, is there a huge difference between 17% and 21%? Both are pretty unlikely. They're unlikely to happen. It's a little off. We probably could get a little bit closer. How we could get closer to the actual probability? If we didn't roll as much? If we rolled more. Yeah, if we doubled this, if we did, or if we all rolled it to 1,000 times total, the more times we do something, the closer we're going to get to the actual theoretical probability. All right, last experiment that we're going to do together, and then you have a little bit of practice. Okay, we're going to find the probability of picking a hearts out of a deck of cards. Normal deck of cards. Probability of hearts. Hearts is red. It looks like that if you need a reminder. Alright, so probability of hearts. How many hearts were there in a deck? 13 out of 52. Or if we simplify it, we could also think about it as it's one shape out of how many shapes? 4 shapes. There's hearts, diamonds, clubs, and spades. So 0.25, so about 25%. All right, this time we are all going to do this 20 times each. So we are going to do this 440 times. We're going to do 440 picks. Now, as we do this 440 picks, what's important is that we're picking it just one at a time. So we're picking a card, putting it back. Picking a card, putting it back. So every time there's still that 13 out of 52. Okay? And we probably would have to shuffle the deck, right? You can't just put it back on top and then grab again, because then you're not going to grab that same card. So theoretically, out of 440, we're going to take 440 times what?
No, 13.
Not times 13. What's the probability?
Oh.
25%. We could multiply it by 25%. Okay, when we do that in the calculator, on Desmos it's kind of goofy. We have to do 25% first, and then we'll put that word of in, 440. And we're going to get, hopefully, about 110 hearts as a class. Okay, so to find the amount that you should get, we're going to take our total amount that we're doing times one part of our probability. We could have multiplied it by 13 over 52. We could have multiplied it by 1/4, 0.25, or 25%. All right, everyone is going to go to Schoology. You're going to go to the Week 3 folder. Keep your notes out. We're not done notes. Go to the Week 3 folder in Schoology. And after the weekly plan, before the practice, there is a link called Random Card Picker. Carmelina, do you want to pass that to Carmelina? In the week 3 folder, in Schoology, there's a link called Random Card Picker. Everyone is going to go to that link. Random Card Picker. You are going to pick 20 cards. So you're going to hit that generate button 20 times. Okay. Or the again. Okay? So you're going to hit that again 20 times. You might need to keep track of how many times you've done it. Oh, I got it on.
So what we need to do?
Go to the random card picker in Schoology. Okay. Alright. Out of 20 times, how many times do you get a heart?
My computer went down. Is it dead? I don't know, I charged it last week. I know, it's on the
Can you take your computer? Ryan, take your computer. No, you're taking your computer for drawing cards. Yep, you're drawing cards. There's your dog. Here we go. Drop the ball. I don't know.
Are you supposed to write that there? What are you supposed to do with it?
Alright, so in the week 3 Schoology folder, you're doing that random card picker 20 times. How many hearts?
Where are you supposed to put it? Are you supposed to write it on the board?
Yeah, can you erase the word from the book? You're going to pick the again 20 times. Yep, so 20 times. So you're going to keep track of how many times you picked. So if you need to keep it on a, you need a separate sheet. That's what you need out school. Oh, you're doing
What is this one? What do I do?
20 times. You're looking for hearts. So you need this again.
That's a heart.
Yeah, that was a heart. So that 1, 2,
Oh, that's what you do.
3, 4. So you got 2 so far. 4. Keep going. So it's 20 times.
So what does this mean? 2, 2.
Okay. I got 5, 6, 7.
That's a heart.
Yep. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. You're doing the card picker?
Yeah, we're about to.
You're doing it 20 times and you're looking for hearts. So on that link, random card picker, you're doing it 20 times, looking for hearts. Did you do one? Need help? Okay. Find the link. Step 1. You did it?
Oh no.
Come on, you did it. Somebody did it. You did it? Okay, you got it? You wrote yours up there? You wrote yours up there?
Question.
And then did you find that random card picker? You all three did it? You're working on it? Or you did it? There's one. wait on like 6 of us to do this. Try and do everything your turn.
Instead, can you borrow my new charger?
Is that my charger? Is that the-
Yeah.
Did your ears open work?
Yeah.
And yours doesn't work. Alright. Tony, did you find what you're doing?
Yeah.
Okay. Did you get a chance to write your answer on the board? Someone will you write 4 on the board for me? Yep. Thirteen. Board. Oh, one more. Okay. Should have asked someone to do it again for me. 1, 2, 3, 4,
You want me to?
6. I'm already halfway, sorry. 11, 12, 13,
I'm very sorry.
14,
Because of my laptop.
15, 16, 18, 1 second, 19, 20. Alright, and then a 2. Someone, thank you. There you go. Alright. There we go. Now we have enough. Alright, 3, 4, 6, 5. There goes to grades. And I lost track. 3, 4, 6, 5, 5. What's below that 5 and 4? 4, 5, 4, 7, 6, 4, 7, 7, 5, 11, 10. Holy cow, some people got some big numbers. 4, 1, 2, 3. Alright, we got 121 experimentally. Alright, so again, it feels like it's kind of far off because 121 compared to 110 is kind of a big difference. But out of 440 times, is being off by 11 really like that big of a deal? No, it's not that bad. So let's figure out probability-wise because that's going to be easier to compare our percents. We were looking for 25%, and we'll be able to see with that 121 what percent we were at, and that might give us a better picture of how far off we were. So we had 121 out of 440. So for experimental probability, you're looking at how many times did it work out of how many times total. Your practice today is going to ask you for both theoretical and experimental. So theoretical is what should happen. Experimental is what actually happened. So 121 out of 440. We're still looking at simplified fractions. So 11 out of 40. And that is a decimal of 0.275. Which if we round to the nearest whole percent, that turns into what percent? 28%. So that time we're only off by 3%. That's pretty close. It still happens relatively the same amount. And like I said, if we spent the whole day just picking cards, could take the whole hour and we would get closer and closer to that 25%. The more times you do it, the more times you get closer. All right, that is our notes for today.